Okay, thank you. Thank you for that introduction. So, good afternoon. I hope you're having a great day here in this beautiful city of Athens and enjoying the conference. I'm excited to be speaking today and present the topic of React Server Components. So the topic is React Server Components. Why should you care? Obviously, React and JavaScript is ever relevant, and with RSC, we have a completely new way to build React apps. React Server Components allow us to fade the boundary between the server and the client to create rich user interfaces with minimal client-side code while still maintaining interactivity and performance. So my goal today is to introduce, motivate, and provide resources about RSC. So this was already pretty much said, but I'm from Norway. I work as a consultant, and I'm actually working with RSC in my current consultancy project. So the talking points of today is going to be, first, rendering strategies. Then we'll get to React Server Components, what they are, how they work, and the benefits and the drawbacks. Then we'll go through the Next.js app router onto best practices and patterns when using RSC in Next.js. Afterwards, I'm going to show you a demo with some examples of RSC. And then finally, I'm going to give my thoughts on the future of React Server Components. So let's begin with rendering strategies. You can't have a talk about web development without mentioning them. It's a crucial prerequisite. And I'm not going to mention every type of rendering strategy and the history of the web here, but I'll pick and explain some relevant topics. And this might probably be familiar to a lot of you. So static website rendering is the most basic rendering pattern where all web pages are assembled beforehand and uploaded as static files to a storage bucket. It can be built with plain HTML and CSS or combined with JavaScript. It's delivered exactly the way it's stored, meaning nothing will change unless the code is changed. And although quite simple and efficient, it doesn't handle dynamic data or interactive websites well, and it's impractical to maintain. A use case could be an informational website for a business, and you could say that this is the old way of making websites, and it's not used very much anymore. The multi-page applications, on the other hand, can handle dynamic data. In MPAs, HTML and data is merged on the server per request and sent as one package to the client. The user will open the browser and is served the merge result. And the entire page reloads per request or navigation to a new page. They can be created with, for example, the ASP.NET MVC pattern or with PHP or Ruby on Rails. Use cases would typically be an e-commerce app. For example, Amazon is an MPA. So what are the pros of MPAs? Firstly, all the page content can be read and indexed by search engines because it's rendered HTML, allowing them to appear in search results and be optimized for it. Then there is no restriction on the number of pages you can add. Performance will be the same, meaning they have unlimited scalability. Last, they can provide more website insights. For example, Google Analytics can create reports for each page. And the cons? They have slower overall performance because they fetch each page as a package of HTML, CSS, and JavaScript from the server as it's being navigated to. They can also require more effort to create features. And they can be harder to maintain because each page needs to be maintained separately. Then we have the single-page application, or SPA. A SPA will typically be a React app of Create React App, or Vite, or Angular app, Vue.js app, etc. It's been the most common way to build an application for many years. In a SPA, the bundle.js file includes everything needed to build the app. The entire HTML is created on the browser as the user opens the URL, and then the page is blank until the JavaScript is downloaded, parsed, and executed. Then the framework, like React, will start building it inside the root div, and then finally loads the data. And after it's loaded, only data in JSON format is needed to update the UI. The use case for a single-page application can be any web app that needs to be highly interactive. So what are the pros of using a SPA? First, they're fast, there's no lag, they've got smooth transitions and instant information present after the initial load. This is because everything is loaded initially and not re-requested per page as with an MPA. Second, they're easy to debug because everything can be logged in the browser because it's browser only, such as data, page elements, and network operations. And third, since everything is downloaded initially, they can work offline afterwards, cache data, and update when possible. But there are some significant cons. Most importantly, they have a slow initial load, which is increased with everything that is built on top, such as libraries. And meanwhile, the user is just looking at a blank screen and then afterwards a bunch of loading spinners. Next, search engines like Google cannot know what is on the page because crawlers read strings and like HTML. So typically your SPA won't show up in the Google search results unless optimized in certain ways. They also need JavaScript to function, and then they cannot be progressively enhanced. And finally, they cannot hide information from the client because the data only exists there, meaning things such as API keys cannot be stored in a SPA. For that, they need a backend or a serverless function. So the key difference between an SPA and an MPA, in an SPA, everything loads initially and only data in JSON format is required to update the UI, whereas in an MPI, the entire page reloads per request. This brings us to SSR, which combines the advantages of an MPA and an SPA. Instead of generating the entire application on the client from the JavaScript bundle, server-side rendering means that you pre-render the initial pages on the server and then send them on demand. This lets the user go to a URL and instantly see a fully formed page with components, and they can start reading the content immediately without waiting for React to build the page. The JavaScript required to interact with the page is then sent along with the HTML. In relation to SSR, we also have something called static site generation, or SSG, which lets us pre-render pages in the build process of the app, and then upload them to a storage bucket. So the result is the same as with the quick and simple static website rendering, but we can generate the pages from, for example, React code. Our problem with SSG is that the build time scales linearly with the number of pages, meaning if you have a lot of pages, you could be waiting a long time for your app to build. Also, you have to redeploy and rebuild and redeploy the site whenever you're going to change your data. So server-side rendering is implemented in the so-called meta frameworks, which are frameworks around other JavaScript frameworks, such as Remix and Next for React, SvelteKit for Svelte, and Nuxt for Vue. These frameworks are full-stack implementations of a web app, meaning they have their own server with things happening. They support both SSR and SSG and can decide when to use what. For example, an app has a couple of pages, which of one has data that is changing. In the build process, all the static pages are rendered, and then when the user opens the app, only the page that has dynamic data will be rendered at request time. These meta frameworks also typically include things that, like file-based routing, APIs to handle data fetching on the server, caching capabilities, and image optimization features. So let's get back to that JavaScript that is sent along with the pre-rendered pages in SSR. We still need JavaScript to run on the client to handle any interactivity. So instead of conjuring all the DOM nodes from scratch, the framework, like React, will adopt the existing HTML, and this process is known as hydration. The framework will attach the event handlers and, for example, fire effects and add state. And afterwards, the page is fully interactive. However, it essentially has to rebuild the entire tree and compare it with the existing one to know what to hydrate. This quote by React core team member Dan Abramov explains it well. Hydration is like watering the dry HTML with the water of interactivity and event handlers. So there you have SSR in a nutshell, done by modern frameworks like Next.js. It lets you load the initial page quickly, yet still have an interactive SPA. Now this sounds great, however, SSR isn't perfect. First, after the initial fetch of the HTML, the browser will download the JS code, parse it, and execute it. This causes the pre-rendered HTML to look fully interactive, but in fact, it doesn't contain any JavaScript yet. So the user is stuck in a place often referenced as uncanny valley, where they will click a button, but nothing happens. And the time until they can interact with the app might even be longer than would have been for a plain SPA version of the app. Why does this happen? First, you have to fetch everything before you can load anything. All the HTML with the data fetched must be processed on the server before it can be sent to the client. Secondly, you have to load everything before you can hydrate anything. That's because React needs to match the tree in the browser with the one from the server. Third, you have to hydrate everything before you can interact with anything. React starts the hydration, and then it doesn't stop until it's done. There are many techniques being utilized in different frameworks to solve the hydration problem. Partial hydration can be used to define that only certain components need to have JS attached to them. For example, in Astro, you can define which components to hydrate with a directive client load. You will also see this in React Server Components later. With progressive hydration, you can lazily load JavaScript, for example, with Astro's client visible or with React suspense. And then selective hydration lets you prioritize which component to make interactive based on user interaction. And this can also be done with suspense. And there are many other ways being implemented in other frameworks, such as with resumability in Quick. Oh. Let's also mention the concept of streaming. It's a part of the Fetch API of ES6, and it's available in React 18 and is a big part of React Server Components performance. Streaming allows you to break down a request into smaller chunks and progressively send those chunks from the server to the client, then render each chunk as it's streamed in. We can use it to send components down to the client as soon as they've been generated. So finally, with all that knowledge, we can move to React Server Components and how they solve the problems that we've been seeing. What if we could decide when we needed the behavior of an SPA or an MPA or use SSR all in the same stack? I'm going to be using some code examples that you will be seeing in the demo app later here. So what are they? React Server Components are components that run exclusively on the server. Server components never re-render. They run once on the server to generate the UI. And their JavaScript is never sent to the client. And when I say rendered on the server, I mean the server that is part of the full stack framework, such as Next.js, or during the build process of the app, not some .NET backend API. This is the front-end's own backend, which in many cases eliminate the need for writing a .NET API. Server components differ from server-side rendering because they are never hydrated, meaning the resulting app is partially hydrated. Hydration to non-RC components can happen concurrently with RC streaming in, since the compute load is shared between the client and the server. Since RCs are run exclusively on the server, we can write database queries right inside our components. So here's an example of a simple server component called JokesList. I can query my database through an ORM like Prisma and have the data available and component fully rendered before it's sent to the client. Server components introduce async components, basically an async function that can asynchronously fetch data from the server without causing any issues for the client side. And you can do any kind of data fetching here, such as calling your API. So because server components are only rendered on the server, this means that a big chunk of React's API is now incompatible with them. For example, we can't use state because state can change, but server components can't re-render. And we can't use effects because effects only run after the render on the client, and server components never make it to the client. We also can't use any browser-specific APIs because they don't exist there, such as window.location, and we can't use onClick and onChange because they require JavaScript. So server components themselves are simple, but the React server component world is more complex. We still want to have interactive components that include state and effects and event handlers. So because of this distinction, there are now two types of React components, server components and client components. Client components are the normal React components that you can do whatever you're used to inside. Note that they are still pre-rendered in the build process of the app and hydrated on the client, such as with the pre-existing SSR. However, client components must be marked with use client. That allows us to use things like state and effects and onClick as normal. So here's an explanation from the Next.js app router docs on the limitations in server and client components. If you need to fetch data, access backend resources, keep sensitive information on the server, or keep large dependencies on the server, use a server component. If you need to add interactivity like onClick or onChange, or use state or effects, or use browser-only APIs, use a client component. So how do React server components work? What happens is that React renders server components into a special format called the RC payload. It is a streamable format that represents the DOM, like a serialized version of a React tree. The RC payload contains the rendered server components with holes of references to client components and the props they pass down to them. It is used both to generate the pre-rendered HTML on the server and to update the DOM on the client without a need for JavaScript. So here's what it looks like in the console. We have the initial server-side rendered HTML of the page, as well as the RC payloads identifiable by the _RC name, and multiple client-side JS bundles. So these are used together to build the interactive page. Since the jokes list component is defined as server only, it doesn't need to be hydrated at all, and its JavaScript isn't shipped. As with everything, it's quite complex when you start digging, so let's just leave it at that for now. When an RC needs to be re-rendered due to data change, it refreshes on the server and seamlessly merges into the existing DOM without a hard refresh, updating only the parts that have changed. As a result, the client state is preserved even as parts of the view are updated from the server. And this is possible because the RC payload only contains references to client components and can leave them untouched. So what are the benefits of using React Server Components? Firstly, data fetching. Data fetching can happen in components before they are sent to the client and will be faster since they can call the API or database in proximity to the resource. And inside RCs, you have access to all your backend resources. Next, they can increase security by keeping sensitive data and logic like API keys on the server and never risk exposing them. Then caching. By rendering on the server, the result can be cached and reused on subsequent requests and across users. And bundle size. Server components allow you to keep large dependencies on the server, meaning you can exclude all that JS for those components from the bundle without restricting your use of them. For example, a library like Lodash, which is known to ship a lot of JavaScript to the client. So that leads to a more performant application. Server components can furthermore be streamed, meaning they can be sent in chunks and viewed as they become ready. Therefore, they integrate naturally with React 18 Suspense. And finally, developer experience. There's a lot less hassle on the client side with effects and keeping data in the state. Just fetch it async off the client. RC, however, comes with some drawbacks. Firstly, they require a framework. In practice, you will only be using them in a framework like Next.js, which is, per now, the only reasonable way to use them. You become bound to the Next.js way of doing things. Second, they create increased complexity. As a web developer, you now need to know a lot more concepts than before when you were just making a spa with Create React App, such as what you can and can't do on the server. Next, it can be hard to onboard new developers because the learning curve is a lot steeper when aiming to write quality apps. And finally, it's still relatively new and not everything has been figured out, such as testing and compatibility with other libraries. You risk having to refactor things or write specific workarounds. And there have also been a lot of bugs since the app router was released, but it seems to finally be settling down now. So how can you get started with RC? As mentioned, the most reasonable way is the Next.js app router, available from version 13.4 and onwards. So Next.js is made by Vercel and is battle-tested and enterprise-ready. React Server Components are part of React 19, but developed closely with Vercel and Next.js, which is good for building apps with them because everything is optimized and working smoothly. So to make a Next.js 14 app, run this npx create command and define whether you want TypeScript and Tailwind and such. And you will need the app router option set to yes to use RC. That will generate the boilerplate for you, and you can start using React Server Components. There's not a lot of files to confuse you. It's mostly standard files such as package.json, tsconfig, and some config for Tailwind and ESLint. What matters is everything inside the app directory. So in the app router, you will be coding server first, meaning everything you do is a server component unless specified otherwise, which means that this layout and page file is a server component by default. In the app router, you define routes by making folders containing a page.tsx. That makes it a valid route. I have some routes here. It's /jokes and then a /new and /joke ID subroute, which is a dynamic route, meaning it's parameterized. Then you can also use files with reserved names such as not found TSX, error TSX, which are error boundaries that render inside the layout of the route, as well as loading TSX, which creates a suspense boundary around the page. And there's also more features like ignoring folders from routes with underscores or grouping them with parentheses. So how do we use React Server Component in Next.js the right way? What are the best practices and development patterns to get the most out of them? The best practice is going to be to move your client code to the leaves of the component tree. In this way, you'd ensure you do not ship unnecessary JavaScript to the client. React will then hydrate only these client leaves, as we know as partial hydration. You could, in theory, just put use client on your root and code however you want, but that means all your components will have their JS shipped and be hydrated, which just takes us back to standard server-side rendering. To use a client component in a server component, you simply import it. Here, the delete functionality has been extracted to a component with use client because it needs an on-click event handler. However, when going the other way around, you cannot do the same without turning the server component into a client component. You instead need to slot them as props, and they will fit as separate chunks into the client tree. The client component does not know what is being passed down. This can be referred to as the donut pattern. This means that our tree can look like anything we want, and we can add client-side logic in the parent components as well. So here, only the green components are hydrated and contain JS. The rest is just HTML. With this pattern, we can furthermore implement things like state management. By providing a wrapper client component with state, for example, using React Context, which only works on the client side, we can use this state in the leaves without converting the server components in between. For example, we can make an error message provider or a theme provider. When combined, this allows us to make apps that are extremely performant due to their large amount of non-hydrated content while still being fully interactive. You could have a donut pattern collapsible sidebar, a theme toggle provider, a search, and buttons on the client side. And then you can share your state between your components however you want. When building an RC component tree, there will be some limitations between the client and the server components. For example, since the client components exist on the client and the server components on the server, props need to be serializable. That means that we cannot pass functions through the server boundary. Instead, we must create API endpoints to communicate between them when we can't use props, or React server actions to simplify the process, which I'm going to talk about later. So how do we manage our data with RC and the app router? I already showed you that you can make database queries through an ORM like Prisma. You can, of course, also use the Fetch API, and there are a bunch of parameters you can add here, such as cache duration, tags for validating the data, and headers, and more. So here's an example showing you what you could potentially do. For example, getting a cookie and making an authenticated request to an API. Getting data this way is in your server components is efficient because on the server you have this privileged environment with everything you need accessible. If you use the same data in multiple components in a tree, you do not have to fetch it in the root and pass it down. You can fetch it in each component where it's required because it's automatically memoized. You can compare this pattern to React Query, where you will call your hooks wherever they are needed, and then they will all call the same cache data. Plus, you can pass it down to client components when you need it, for example, as the options of an autocomplete component. So what about data mutation? I mentioned that you can create API endpoints like in the Pages router, but let's skip that for now and look at something way better called server actions. They just became stable with the release of Next 14, and they are the preferred way to mutate data. They kind of complete the whole React Server Component story. It's simple. You mark a function or file with useServer, and Next.js will make a hidden API endpoint for you, allowing you to call it from anywhere, like from a client component, solving the problem of passing functions between the server and the client. And in addition, it gives you type safety between the server and the client through RPC. So here I have a file marked with useServer, turning the function inside it into a server action. And that means I can now call it from a client component. And that's it. However, I also need to tell Next.js that I have changed something inside the data of the RCs, and it needs to revalidate the view and fetch new data from the database. Looking at our data management graph, the server action seamlessly takes us back from the client to the server again, without making any API endpoints or anything like that. Server actions also integrate nicely with form submissions. So here I have a form and a function marked with useServer. When submitting the form with the action property, it can, without JavaScript, call the server action and add a joke to the database. And again, I need to tell Next.js to revalidate the view. So that's just some quick examples. There's so many possibilities here, and it's extremely efficient to develop with. So there you have it. React Server Components in the app router allow you to do whatever you need to do, whether it's MPA functionality or interactive SPA stuff, and include SSR or SEO optimization, or I guess that's just SEO, or any kind of functionality you need, all in the same stack. So it's quite amazing. So hopefully you remember some of these terms. It's a lot, and React Server Components definitely bring a new mental model and architecture. Let's get into a demo of the joke app. So, this is a rebuild of an old Remix tutorial. It's using the app router, Prisma as an ORM with an Azure SQL database, and Tailwind for CSS. And it's deployed on Vercel, so I have like a bunch of caching and stuff here. So it's pretty simple. It has the jokes list component, which is a server component, which you can use to view different jokes. And then you can add your own. For example, cache. Why did the developer go broke? He used up all his cache. So we can add that. And then we can also delete it. Yeah, so let's look at the code for this. I'm just going to use my local here. So this is pretty much the boilerplate that you recognize from the presentation. And then I have some validations for forms, Prisma stuff, a lib, which I'm using as my data access layer here with actions and services, components, and the app router. So here I have the jokes folder, which makes this jokes route here, with a layout and a page. And the page is just displaying the random joke. And then the layout is responsible for header, sidebar, which is, it's not a sidebar here in this responsive view, and the footer. So all of these components, the header and the footer, are just links pretty much, and are never hydrated and never sent to the client. Meaning the only thing here that is requiring JavaScript is going to be the specific parts. For example, I have, let's see, a random joke button, which is this, which is using some JavaScript requiring APIs here, such as router refresh. So that's why I'm marking it with use client, so that it will access this JavaScript and have it loaded to the client. Then this jokes list is what you also saw from the presentation. It can just asynchronously await a function, which is getting data from the database, and map it to links, just like that. And it's not hydrated at all, because it doesn't need to be. Then the new route, which is here. I have a page, excuse me, with a form. So this form is using the action property to call a server action on form submission. And I also have this feedback here when you click the button saying adding, which requires interactivity. So that is a client component as well. And it's using this upcoming React 19 hook called useFormStatus, which lets you get the state of a form that is currently submitting the server action. So it's just displaying adding with this pending state here when I'm adding something. We can watch that again. It's a client component. It's going to have this extra interactivity. There you go. It's up there. And then this action is mapped to server action, or is bound to server as server action, which is defined with useServer. So now this function has been, there has been generated a post endpoint so that we can call this from anywhere. And it gets the form data, which is each field here from the form, and then you can insert it into the database. And then revalidate the path means that we tell Next.js to re-render the server component on the server and merge it into the view again. Then you can also delete it with some feedback here. So let's look at that. Inside the joke ID route, which is now getting params here to get the right joke with a get joke. This is just a function, excuse me, which is getting a joke based on the joke ID from Prisma or from our database. And in here, I have a delete joke button, which is also requiring JavaScript on the client to give us this feedback. So it's a use client directive, or it's a client component. And here I'm using a React 18 feature called use transition, which is a way to keep the app responsive as something else is happening. So it's also returning to us this is pending flag, which I'm using to disable the button while the delete joke server action is happening. Yeah, pretty much. And this delete joke just deletes from the database. So now I'm tracking this action with a transition, and it will give me the the pending flag to create the deleting feedback. Yeah, but I also have some more things here in this app. I have some demo routes to show you some of the concepts I've been explaining. So first, I was talking about the fact that, hold on, that you can put server components and client components if you slot them as props. So you have a server component and a client component, which is doing something interactive, and a server component inside. And this is possible if you put it like this, using the donut pattern, because this server component is now only a reference, and the client component doesn't really know what's being passed. It's just rendering whatever the reference tells it to render. So now I can have this console login here, and it's only being rendered here, and on the client, this is being rendered. So now we have these separate parts of the application, which is doing its own thing. Next up, revalidation. Basically, this is just to show you that if you add some client-side state, and then add some more use server action to revalidate the view, you can add something, and the client state is preserved here, even though you just refreshed the React server component. Global state. So with this donut pattern, you can now have theme providers that can control your state and then give you functions to use it. So it looks like this. Hold on, sorry here, I'm going to move this back. So here, I have a theme connex provider, which is containing server components, this one, and then a component to set the theme, which is a client component, which uses the theme context to set the theme. And then another server client component, which can use the theme context to display something based on the theme. And we can still have server components in between here because of this reference-based technology. I have a bunch of examples of forms here. I'm not going to go through all of them that detailed, but you can look at this later if you're interested. So in a server validated form, we can have a server action that can validate your data, for example, using Zod. And as you will see, if this is not valid, it's going to give you server, or it's going to log here on the server, because that's where we're doing the validation. And then we can also do it on the client. So I'm using Zod here, but on the client, in a client component. And when I do something that's not valid here, it's going to log it on the client. And you can combine this to make like really smooth interactive forms, for example, using reactive form on the client and then a second like safety on the server, because you should always be validating your data on the server as well. So I'm using reactive form to display this feedback here. And then I have a stricter validation on the server, so it's going to fail because of the server validation. Maybe I changed something since last time. OK, and I'm going to make sure this is working, but it was working this morning. I think I changed something. Anyway, and you can make fully progressively enhanced forms using multiple new React 19 hooks, which will let you create forms that will validate on the server and return to the client without JavaScript. So this is pretty amazing that you can do this now in React. Then suspenses are a big part of rendering your data, because if you're awaiting something, you need to split it into parts so that whatever is taking longer will not hinder the rest of the app from rendering. So looks like this. I have some different timeouts. So I'm having some here, which is now rendering our loading error boundary, which is this first fallback here. And then for each part, which is its own timeout, it's going to render pieces as they become ready. So I have suspense here, and one here, and it will, as you can see, kind of render each step as the data from the server becomes available. And I can still click this even though it's still getting something from the server. You can also use React Query. Most of the time, you don't need to, because you can just get it on the server. But if you do, you can use it, for example, for polling, like time-based, getting data. And there's a specific way to do this, which is in the code. And you can also use server actions. I'm going to just find this here. Forgot where I put this. Here. You can also trigger server actions from, for example, on blur, and then use it to get feedback when something's happening. So this is just an on blur server action triggering a save. I think that's it for the demo. Yes. Thank you.
Thank you, Aurora. Thank you.
I have just a few more slides here, just quickly summing it up. I have 5 minutes, so this should be OK. So as you can see, this app is pretty small, but I didn't really try very hard to optimize it. It's just optimized by default by following these patterns that I've been talking about. So all in all, you can build really performant apps, and the limitations of RC will kind of make your code better, unlike in plain React, where you can do whatever you want. So to finish this off, what is going to be the future of RC? There's no doubt that this is the way React is going now. It's not just some hype cycle that's going to die out. It's the result of many years of work from the React team. It's likely that other frameworks are going to implement these RCs or their own versions of them. Actually, Remix have announced that they will, but they're taking it kind of slow and seeing how the progression is going first. And there are a lot of solutions being proposed to improve the web performance in apps, but the goal is always going to be to find the optimal balance between UX and DX, and this is kind of React's take on that. So nonetheless, there's still a lot of things to be figured out as React Server components are battle tested. So here's the repo for the joke app. I really hope that these reference pages can be useful if you're going to make something similar. And some more resources that I used during my RSC learning process. So the Vercel docs, they're very good. And you can find, just make sure that you use the app router version, because there's also a pages router version. And Vercel has a bunch of template apps to reference, and they have recently released a free course, which is like a full walkthrough, going through all the concepts and then deploying it to Vercel. And for YouTube, ByteGrad does a lot of RC content, and Code with Antonio does like full walkthroughs of rebuilding, for example, Twitch apps, Miro, and it's really good if you want to see kind of these best practices in a better, bigger context. So I highly recommend this. And as I mentioned, I do have real-world experience with RC, and I've felt kind of the struggles and the wins. So if you want to talk about it, just come chat with me. I just don't have time for that today. So thank you for listening. That's it. Thank you.
Thank you, Aurora. Thank you.